Okay, so what's the lesson now? The concept of carbon concentration in leaf. Actually, we are talking about the location of the carbon, location of CO2, carbon dioxide. You have a leaf. Let's take a cross section of the leaf. You look from the side of the leaf. So that's the top part of the leaf, which is the adaxial. Then that's the bottom part of the leaf, which is the abaxial. Then you got your stoma here. You got your stoma here. So that will be the abaxial. Right. So in here we have our cuticle layer and stuff. You got your cuticle. Maybe sometimes you got trichome or hairs and so on. Right. So the tissue, the leaf tissue in here, we got what we call as the mesophyll cell. So usually for the C3 plant, you have something that looks columnar and orderly arranged. So this region here we call as mesophyll cells. Okay. Mesophylls means photosynthesizing cells. Photosynthesizing cells. And the other one is sometimes you got loosely arranged mesophyll. So this is spongy mesophyll. Now let's talk about CO2. CO2 can be present in 3 locations, namely, right? So you got your CO2 location. There are 3 in essence. Okay, number 1 is Ca, ambient or atmospheric CO2. Then you have number 2, which is Ci. Stands for intercellular CO2. And then the third one is Cc, which is, what's that? Chloroplastic CO2. So where are these things actually in relation to the leaf cross section that you have here? So Ca is whatever outside the leaf. Ca here. So these are all the CO2. Yeah. The moment the CO2 enters the leaf and it's in the voids in between here, I should be using different color now. You know that it's in the void here. It's called Ci. So this is Ci, intercellular CO2, in between among the cells. The moment CO2 has entered the cell, it's called Cc. Okay, Cc stands for CO2 that has actually entered the chloroplast. Okay, so CO2 in the form of in the ambient, which is still gas, and then Ci, CO2 still in the form of gas, but Cc is in the form of liquid. The CO2 has dissolved in water, turning into what? Carbonic acid. So the issue now here is one parameter known as Ci-Ca ratio. This thing here. So what's your scene now? Let's say that you have 2 readings. You have one reading, which is your sugarcane, which is 80%. And the other one is 60%. 80% CI/CA ratio means that the CO2 drawdown drawdown by the chloroplast to become CC, chloroplastic CO2, is rather low. That's why you are having this high number when you are only talking about the CI/CA ratio here. So you can think of, like, if I put it into timeline here, we start with CC, then we go to CI, then we go to CA, right? If the demand here is high, more of this will go in here, correct? More will go in here. When this CI is low, what will happen to the percentage? Yeah, it will become low. So originally, from 100 over 100, because the demand is so high, now it becomes maybe 50 over 100, meaning that 50% of CO2 that is available to the leaf has entered the void in order to satisfy the chloroplast demand. But if the demand is much less, very less, so the demand is not that great, what is given is still 100. But let's say that the demand is not that great. Let's say that the demand is only, it can give 100, but it only uses what? 20. 20 over 100, when you put it into perspective, this is actually this thing, 80%. Meaning that only 20% has been sent to the CC. 80% still stay in the CI. It's not going anywhere. Why is it not going anywhere? There is no demand here. Meaning that either the photosynthesis is not high or the plant is just not ready. Yeah.
Oh, that's why the next one they just very low.
Yeah. So, get it?
Yeah.
If you're not getting it, I will make the second video. Bye. So what's your dose?